Hello listeners, this is Liam from Learn STEM back with another episode. In today's episode, this is going to be a special one because I'm going to show you all the science behind slime. In this episode, the first part, I'm going to talk about the chemistry behind slime and all the special facts and details that you'll want to know in this slime making process. The second part is when I'm going to show you guys how to make slime, and I'm going to give you guys a general recipe to make slime. And then the third part is, if you guys want to stay tuned to the end, some ASMR behind slime. So let's get into it. The first big ingredient that you'll probably know that we want to include in slime is a type of glue. This glue can be white glue, clear glue, woods glue, any type of glue. But for this specific slime making process, I'm going to be talking about PVA glue. Most slime is based around having PVA in its chemical makeup. The reason is because PVA, or polyvinyl acetate, is so important in the slime making process is because it has long polymer molecule chains. This results in a highly viscous and sticky liquid. And as a side note, this sticky liquid is what allows glue to stick to porous materials. And then as the moisture evaporates from, this PVA glue, that means that it will get hard and cause those two materials to stick to each other. So this aspect gives slime a glossy texture, and I will show you guys an example later. However, in mass-produced slimes, they use, I'm gonna have to sound this one out, organosiloxane silicones, which is a type of polymer which is more durable than PVA-based slimes because it has a longer shelf life and it has better durability in play without as much effort to keep it up. But often the long silicone chains affect the glossiness and the texture of slime, making it too unstretchy, and it does not allow the slime to, be that quality slime that usually on TikTok or something. So let's draw an example of polyvinyl acetate for you guys to visualize what it looks like. Okay, and this is my DIY whiteboard because I do not have a whiteboard. So let's get into this. So polyvinyl acetate. Let me make sure to spell it right. Okay. So polyvinyl acetate. This is the 3D kind of look at it. So sorry, I have my notes pulled up right now, because I do not have these memorized. So, it's quite a long polymer chain. And then here is the more scientific one, where it shows you all the bonds in the specific chemicals involved, atoms, sorry. Okay, so its chemical property is that it has C4H6O2N. N is basically just the repetition of this long polymer chain. C is carbon, H is hydrogen, and O is oxygen. So, as you can see, it consists of two trigonal planar chemical bonds chemical structures with single bonds and then a double bond on the oxygen. So it has a molar mass of 86.09 grams per mole, which is the amount of mass per a mole. And a mole is 6.023 times 10 to the 23rd amount of molecules or atoms in a given quantity. And it has a density of 1.19 grams per centimeter cubed, so it's a little bit more dense than water. That is, of course, at 25 degrees Celsius. So it has another extremely interesting chemical property, and that is its degree of polymerization. So that basically means that polyvinyl acetate its degree of polymerization is from around 100 to 5,000, while its ester groups, which are the groups of naturally occurring carbon and oxygen in trigonal planar, which is this triangle shape, it's nonpolar. So that means that it's sensitive to base hydrolysis, and it will slowly convert into PVAC, not PVA, which is polyvinyl alcohol and acetic acid. This is observed in slime for the phenomenon of, you know how like when you leave slime out, that means that you need to add more borax solution or activator in order to make it that nice texture that you want to play with. Otherwise, it will become too sticky. So that is why you need to, add that more activator to de-stickify it, if that's a word. Now we're going to move on to the borax solution. So the activator is this borax solution, and I have a bottle of it on screen, which is going to come up like right now. As you can see, it is quite clear. It actually is clear, and it has a slightly like chemical-y smell, but that's from the borax. And then if you want to make slime, I'll go over this again later. It's 1 teaspoon of borax powder into 1 cup of water. And you need to heat up that water to accelerate the mixing process to make it a homogeneous solution. So the borax or sodium borate is what binds the glue to itself. So think of this action done by borax as how when that glue wants to stick to porous things. So that borax makes the glue, instead of stick to other things, stick to itself. So this is what binds the slime into one, nice texture instead of having it be all over the place. However, beware that slime still needs to have a sticky property to work, as in it needs to be able to stick to itself. So when you add too much borax, it will not be able to stick to itself, and it will just be, this hard blob that you cannot even play with. And the long polymer chains will be stuck and cannot rearrange themselves to give a stretchy quality to the slime. And, when you try to stretch it, it will just break apart. And that, you never want to have a slime that does stuff like that. And then additionally, this signifies that when you add borax to the slime, it might stick to your hands a little bit, but you just need to play with it in quick hand motions, not long, or else it will still be able to go into the grooves, the tiny porous grooves into your skin and stick to them. And this basically means that when you add enough activator, you should be able to play with it fine on non-porous surfaces like a table, in your hand, but it will still stick to things like your shirt because your shirt is extremely porous and will absorb the slime and get stuck. But I digress. Described as sodium borate, which is the generic name for boron and oxygen that has crystallized into a salt. But remember, salt in chemistry is not, the NaCl that is seen on your table. It signifies that the structure is made up of positively charged cations and negatively charged anions that are organized into a crystalline structure. And then, so let's draw this out on my DIY whiteboard. Okay, so here is a finished sodium borate chemical diagram. As you can see, it's very long and it's quite complicated. So this just, is for if you want to see what it would look like in its chemical compound. But basically, so it's Na2B4O7, and it's the version of sodium borate that is anhydrous. And then this chemical compound, which is Na2B4O7, is commonly shown with X, Y's, and Z's, meaning that this formula can be often changed to make different outcomes. So the anhydrous part of it means that basically this will dissolve in water, which is important later on when I'm going to talk about that. So it has a molecular weight of 2 or 1.2, so that is, the mass divided by the molar amount, and it has a density of 1.73 grams per centimeters cubed. So back to that anhydrous part. So because it is anhydrous, it will dissolve in water, just like table salt that you have on your table, and has become ready to add into glue to activate it and to become slime. Okay, and this is kind of an add-on, but the reason why water is so good at dissolving things like the sodium borate is because water is known as the universal solvent. So water, H2O, is polar, meaning that at one end it has a negative charge, and at the other end it has a positive charge. This means that for the salt, which is the sodium borate, which also has cations and anions, so positively charged and negatively charged particles, it means that water grips on to, whether it be the positive end, it would grip onto the negative end of the sodium borate, and then for the negative end, it would grip onto the positive end of sodium borate. This polarization of a molecule, H2O, means that it will effectively grip on and dissolve the sodium borate solution effectively and quickly, especially when the water is hot, or when it is stirred, or in change of atmospheric pressure. These three instances in chemistry can change the time it takes to dissolve something by mixing it, heating it up, and changing the pressure around the surrounding liquid. So that is why water is such a useful solvent to dissolve a solute, especially in slime making. So let's get back to the video. We have covered most of the actual parts that go into making slime, but there are more that you can add to make, even better slimes. So I'll give you an extra with 2 quick bonuses at the end for what you can add into slime to get a great slime. So the next is vegetable glycerin, aka glycerol. This is a triol compound, meaning that it contains 3 hydroxyl groups, which is just oxygen and hydrogen. So it's commonly used in lotions and moisturizers, to add moisture back into anything like your hands or whatever. So let's just call it glycerol for right now. I hope I'm saying that right. I was not saying right. It's pronounced glycerol, not glycerol. So just to let you guys know. And then it has, 3 hydroxyl groups. As you can see, that is pretty easy to comprehend. So it has a chemical formula of C3H8O3. And then so it has a molar mass of 92.094 grams per mole. And it has a density of 1.261 grams per centimeters cubed. So this moisturizing aspect of vegetable glycerin means that it will reintroduce moisture into a slime. So that meaning that the slime will become less stiff. This is because the glue that is a major component in slime naturally dries up over time, and then if you think about glue in your everyday life, that means that when glue dries, it becomes hard and it sticks. So when it reintroduces the water into a slime, it will make the glue not be as hard, and it will, make it back to its normal stretchy self. So people commonly use lotion or water as a way to reintroduce this moisture into slime, but glycerin is quite useful because it is odorless and colorless, meaning it will not change the smell or look of a slime, but it will just make it nice to play with. So for the bonuses, I was talking to you all earlier. So you can add texture into slime by, adding pieces of beads, clay. So the beads, give it crunch and stuff like that, while the clay will make it more smooth. So also you can further add, this is just a fun one, you can add little sponges to a slime, and then those pieces of a sponge will absorb the slime. So when you press down on it, bubbles and pops will come out of it, which is quite fun. So let's get into slime making now that we have finished. Okay. If you guys are ready, I'm ready. Now, let's get started on making some slime. So, I don't really have an exact recipe for making slime, but I do have an exact recipe for the borax solution. As I've stated earlier, it's 1 teaspoon of granulated borax, or as we now know, sodium borate, to 1 cup of H2O, which is water. So, now that we have that out of the way, I like to just add, a little bit of glue. So it kind of just depends on how much slime you want to make. So if you want to make a lot of slime, then of course you want to pour a lot in, but for right now I just want to make a small batch. So also remember that you have to put in glue and borax and glycerin and lotion after. So if you want to make a medium amount of slime, just don't put too much glue in, because the amount of glue that you put in is not going to be the final amount. There's always going to be some more. So this is the viscous, glossy texture of the PVA, which, as we know, is a long polymer chains. Actually, let's do some more. Because why not? Because we just got midterms over at Gov School, so yay! Okay, that's quite a bit, but then again, we're going to make quite a bit of slime for this special occasion. Okay, so now we have our glue, which is the base ingredient of all the stuff that we're going to do next. So I always like to keep one hand clean so we can use all our other stuff to make the slime. But now, and then the other hand is used to mix in the slime. But now this sticky glue is now the base. So now we have to add in our borax solution. And it's kind of like watching magic happen because it happens really quickly. Okay, as you can see, we've pretty much cleaned out our bowl so far. So now it should be sticky enough where it will not stick to this table, and yes, that is good. Okay. As you can hear, it sounds pretty nice right now. Let me show you. Okay. So now that we have a nice slime, it, has that nice like bubble pop thing. But one problem that you might want, well, you don't want a problem, but for this slime, it's like great for, pops and like pokes, but it is not that good at stretching. You see, it just rips. So one way that we know to do now from our chemistry of slime is that we can add glycerin. Glycerin and lotion. So glycerin, breaks down those polymers so that it can become more stretchy. And it helps retain what's it called? The gloss factor, if you will. See? We have gotten it to where it is way more stretchy than it was originally. And if you want it to be buttery smooth too, you can add modeling clay. You can test out different types that are best for yourself, but any type of modeling clay from a craft store should allow the clay to become very stretchy and soft, and it should pillow up, which is always a bonus. And then, I don't think we need lotion right now, but lotion, it comes with fragrance oils that are safe to use on the skin, so you can always use a lotion to add some fragrance if you want. But now we will go on to adding color. So I have fondant coloring, which is really it's safe to use, except it is very potent, so you want to make sure to use a toothpick and then take the tiniest bit and add it add at a time. Because if you want to have a pastel color, you literally just want to stick the tip in, and then you don't want any more. So what color should we do? We should probably divide this up so we can make the Learn STEM logo. Now that we have divided up, we need to be extra careful to not add too much, because now even the tiniest bit will make this small amount of slime extremely colored. 28 minutes. Jeez Louise. Guys, rate this slime from 1 to 10. Okay. Are you guys ready? Here is the ASMR session.